All right, now we're going to go ahead and remind ourselves how we just kind of simplify things in algebra, numbers and variables and the like. So we want to be able to simplify numerical expressions and be able to evaluate algebraic expressions that have variables in them. So let's go ahead and get some vocab out of the way. A lot of this is just vocab. So it's been a while, but if we say expression in algebra, we just mean a symbol or a collection of symbols that represent a number. So there can be actual numerical expressions, or we could have algebraic expressions. So a numerical expression is just what you think it would be. It would be any sort of collection of symbols that's just a number. So like 17 or 1/4 plus 3 would represent 3 and a fourth. 6 times 2 would represent 12. 4 minus 15 would represent negative 11. So those are all numerical expressions. An algebraic expression, same idea, except for now we have variables. So x plus 3, or something like x plus 6 over 2, or y squared, or any collection of symbols. It still represents a number, it just uses variables instead. So x plus 3 is still some number, we don't know what number it is until we plug in a number for x. So we have numerical and algebraic expressions. Well, along with that, if you set two expressions equal to each other, you create an equation. So an equation is just a mathematical sentence showing two expressions are equal to one another. So some examples: x plus 4 is equal to 3. So those two expressions are exactly the same thing. So x plus 4 and 3 are the same thing. 6 plus 7 and 13 are the same thing. 2/5 and 0.4 are the same thing. Those are just some examples. But not all expressions are equal, so you might want to work with the fact that maybe they're unequal, they're not equal. So an inequality is a mathematical sentence showing one expression is less than, greater than, less than or equal to, or greater than or equal to another expression. So for example, we know that 4 is greater than negative 151. Algebraically, we could say some variable x is greater than or equal to the absolute value of some other variable y. And 12/15 to be less than or equal to 10. Those are just some examples of inequalities. All right, so let's remind ourselves what we're allowed to do in algebra as far as operations are concerned. It's the same four you're used to. So addition would be when you add two numbers. So for example, 5 plus 3 adds to 8, and we call 8 the sum. So 8 is the sum of 5 plus 3. You could subtract two numbers or two expressions. So 3 minus 5 would be negative 2, and that negative 2 would be the difference of those two numbers. Now keep in mind, subtraction is technically not needed at all. We just use subtraction for a convenience in algebra. We could just do without it entirely. If I want to do 3 minus 5, I could just do 3 plus negative 5, which would be negative 2. So I can just not use subtraction at all and just do plus the opposite. So I'll still use subtraction. I'll still say subtraction because it is convenient. That's why it still hangs around. But technically speaking, we could do without subtraction in algebra. Well, the other two operations are multiplication and division. So multiplication, we've got, for example, 4 times 5 is 20, and we call 20 the product of 4 and 5. Division, 15 divided by 3 would be 5. 5 would be the quotient. So just, again, some vocab. And similar to addition and subtraction, technically we don't need division. Again, division's just around for convenience sake. So if I wanted to do 15 divided by 3, I wouldn't have to use division. I could just say that's 15 times 1/3, which is 5. Same answer. So I can just not worry about division whatsoever and just use multiplication and get the job done. But we're not going to do that. We'll still use division. We'll talk about it. And again, it is convenient, so that's why it hangs around. All right. Well, we'll deal with exponents a lot, so let's just kind of remind ourselves how those work. So let's have the variable x be an element of the real numbers. So x will be any real number. Let's have n be an element of the natural numbers. So n will be 0, 1, 2, 3, 4, 5, 6, 7. Well, technically natural number will be 1, 2, 3, 4, 5, 6, 7. So if you have x and you raise it to the nth power, the number that's being raised to the power is called the base, and then the power is either called a power or an exponent, whatever your personal preference is. So if you have x to the n, what that means is you're going to multiply the number x n times. So there are n of these, and you multiply them all together to figure out what x to the n is. So for example, if you have 3 to the fourth, it'll just be the base, which is 3, times itself 4 times, because the exponent is 4. So 3 times 3 times 3 times 3 be 81. What about x to the 0? I know I said n was a natural number, but we'll go ahead and worry about the exponent being 0 also. If any number is raised to the 0 power, so x is any real number, it's raised to the 0 power, it's always equivalent to 1. Now, I'm not going to give a mathematical reason. It gets a little heavy for what what level we're at. But I can give an intuitive reason, maybe convince you why any number to the 0 is 1. So let's take the base of 4. If you have 4 and raise it to the first, you get 4. If you have 4 and you square it, you get 16. If you have 4 cubed, you get 64. So 4 to the first is 4. And then to get 4 squared, you multiply by 4 to get 16. And to get 4 cubed, you multiply by 4 to get 64. Well, if you go the other direction, 64 divided by 4 would give you 16. Divided by 4 would give you 4. So if we continue that pattern, if I divide by 4 again, so divide by 4 here, well, we have 4. We divide by 4. We end up with what we said it would be, which is 1. So 4 to the 0 would be 1. So just more or less an intuitive reason, maybe to convince you why a number to 0 is 1. All right, again, just some more vocab, some more things we're going to use right off the bat in algebra. Substitution, kind of what you're used to. You can replace one thing with another. So if you have an expression and you want to swap it out for something else, you can swap it out for any other equivalent expression. So as long as they stand for the same thing, they have the same value, then you can swap one in for the other. And we'll do that here in a sec. Again, now's a good time to remind us of the order of operations. You have to do things in a certain order when you're simplifying in algebra. So first and foremost, you always check parentheses and brackets. So you locate any parentheses and brackets, and then you try to find the innermost parentheses or brackets, and you work on those first, and then you work outwards from there if there's other parentheses or brackets. Now, while you're working in any set of parentheses or any set of brackets, you have to do exponents. Then after that, you have to do your multiplication and division, working left to right. And then last, you can do any addition or subtraction left to right. So you got to follow that while you're working inside any parentheses or brackets. If there are no parentheses or brackets, then you just go straight to exponents, and then you do multiplication, division, left to right, addition, subtraction, left to right. All right, so let's give it a try. So we have 2 times 5 minus 6 divided by 3. So we do have a set of parentheses, but there's just a 5 sitting in there. There's nothing to do with that 5. It's minding its own business. So we move on to exponents, but there aren't any exponents other than to the first power, which doesn't change anything. So all we need to care about are multiplication, division, and addition, subtraction. So starting left and working right, we want to do our multiplication and division. So we'll have 10. 2 times 5 is 10. And then we have to do the 6 divided by 3 before we subtract. So the subtraction just carries down, and 6 divided by 3 is 2. And then lastly, we do the subtraction, which will give us 8. So addition and subtraction come last. In B, we do have some parentheses and brackets. So the parentheses are the innermost, and so we're going to work on those first. Well, inside those parentheses, we have an exponent and subtraction. Well, we have to do the exponent first. So everything else just minds its own business, and 2 cubed is 8. And now inside the parentheses, we can do the subtraction. So everything else minds its own business. We end up with 7. And then we do the bracket. So inside the bracket, 4 plus 7 is 11. And then we can lastly do the multiplication and get 22. For this last one, we have this fraction. And anytime you see a fraction like this, and there's anything to be done in the numerator or denominator, you want to think of that as having parentheses on it. So that 1 plus 5 would have parentheses on it. So we need to do the 1 plus 5 first. So it'll be 5 squared minus 6 divided by 2. We do the exponent, we do the division, and then we do the subtraction. Get 22. All right, so sometimes we want you to evaluate an algebraic expression. So when we say evaluate, we're basically asking you to find the numerical value of an algebraic expression. So there's going to be variables. We want you to plug in some numbers and simplify, see what the value ends up being. So we got a couple examples here. So we're asked to evaluate these two algebraic expressions if x is 4 and y is 3. Well, since x is equivalent to 4, we're allowed to place 4 anywhere we see an x. That's using the substitution property. So this would be 3 times 4, and then 4 squared minus 8. And then we use the order of operations. So we'd have 12, and then we'd have a 16 minus 8. And then we'd have, from there, we have a 12 over 8. And then we can simplify. So that would be 6/4 or 3/2. Notice I used parentheses when I plugged the 4 in. I highly recommend, and will constantly remind you to do that. So for this other one, let's go ahead and plug in 4 and 3. Notice I'm using parentheses anytime I plug in for a variable. We'll follow the order of operations. So this would be 16 times 3, 4 times 9. We got to do our multiplication and get 48 and 36, and then we can subtract and get 12. So we evaluated those algebraic expressions and found that this one's equivalent to 3/2 as long as x is 4 and y is 3, and this one's equivalent to 12 as long as x is 4 and y is 3. All right, last thing. Don't forget absolute value. We talked about that in the previous section. Let's go ahead and plug in 3 for x and -2 for y. And we're going to apply our absolute value rule. So let's remind ourselves, the absolute value of any real number is either the number itself, as long as that number is 0 or positive, and it's the opposite of that number if the number that is inside the absolute value is negative. So absolute value of 3, well, that's a positive, so the absolute value of 3 is itself 3. The absolute value of -2, well, -2, that's negative, so it'll be the opposite of -2. So it'll be opposite of -2. So we end up with 30, and then negative is a positive. So we end up with 32. So that about does it. Not a lot in this section.